Our next speaker is Telma from the Universidade Federal do Rio de Janeiro. She is going to present a joint work with Sue. So her talk will be related to addressing mathematics anxiety in high school in Brazil. Thank you.
Thank you. Thank you very much for this opportunity. Thank you all. It's a pleasure for me to present. I'm trying to bring my experience with the models that I learned from Sue and to a high school in Brazil, okay? So our theme is Addressing Mathematics Anxiety, a case study in a high school in Brazil. And we had this paper published recently, which it was very good to come here, to arrive here and have this paper published. So I'm doing some introduction, but my focus will be on the study as you presented all the definitions, and I'm trying to rest more time on results and discussion, okay? So the idea is that we have math anxiety, which relates to the physiological and behavior reactions that the students have that interferes in learning mathematics, right? And we know that actions can be done to reduce this kind of anxiety and to build what we call the mathematical resilience, which is a construct very particular because there are resilience in other areas, but the resilience we are talking is a specific one because of the difficulties in learning maths. So many authors say that it's a particular one, and many actions can be done to reduce this anxiety, okay, and to develop mathematical resilience. So these actions can be including mindfulness, managed breathing, and writing. I'm working now here in the UK in the one-to-one interventions and next in the group interventions. But what I did here in my class was a group intervention, right? So we explained them how to use the tools so that they could build resilience. That was the main issue. So the model is grounded and directed by a complete understanding of how trauma exposure affects service users, neurological, biological, psychological, and social development. So we based our research in this Scottish report by Holmes and Grandison, and we tried to apply it to mathematics anxiety, and we created this anxiety-informed mathematics teaching, which is the necessity to adopt practice that raises awareness of anxiety, recognizes mathematics anxiety in learners, and seek to resist causing further harm, okay? So the idea is that the interventions can produce or can build mathematical resilience, reducing mathematics anxiety, and creating this environment of anxiety-informed mathematics teaching, okay? So the need to include emotions in mathematics and science education has been reinforced by many authors and underpins the necessity to introduce strategies to develop mathematical resilience and solve the mismatch of the pedagogy of mathematics teachers, which is usually rote, tedious, isolated, and what anxious learners need to thrive when learning maths, okay? So the context I give you is that the prevalence of math anxiety varies widely. We have a lot of samples and measures, but although in most of the studies the measures are the same. And we can say that it's about 30% in the UK and around 49% in Brazil. And in general, high-level anxiety is associated with lower level achievement. Although Flavia showed that it can also also have high-level achievement and math anxiety. So in Brazil, there is high math anxiety and lower level achievement according to OECD 2013. And the emotional factors play a large part in mathematical performance. And math anxiety plays a particularly large role in this. And what we did, we tried to introduce the 3 tools to build mathematical resilience. So the Lugalha's GZM model, the Siegel's hand model of the brain, and the relaxation response. Okay? So the idea is that we try to show them this model, and we call your attention to the growth zone. So the growth zone is where we want students to be, but it's not easy to be this area. It's very difficult, and we have to develop value, which is related to autonomous motivation, the growth mindset, because they come with a fixed mindset, oh, I'm not good at maths at all, so I won't do that. So relationship always also asking for help, asking for support, this is very important. And struggle, the need for persisting, meeting challenges. So this growth area is the tricky part, I think, of the 3 model, okay? And we developed this enhanced GZM model, which Sue showed you. Okay, so we presented the hand model of the brain, which is a way to teach students how to communicate, oh, I'm not okay. So try to make them connect the rational part to the emotional one. So I come back, so I'm here now. So this was very important. Benson's relaxation response was important as well, because they learned how to breathe, and breathing is very important. Singing or saying a word, so calming down so that they could learn maths, okay? And so now I'm going to present my study, so we performed an intervention to promote mathematical resilience in students of the 2nd year of an ICT-based course in statistics. So we had 32 students, 9 males, 23 females, aged 15 to 17, and the whole intervention was 16 weeks. The methodology we used was participatory action research, and the participants collaborated with the action researcher. And qualitative data was analyzed using deductive latent thematic analysis, and we tried to work with subjective experiences using the mathematical resilience framework. So the main objectives were to assess the level of math anxiety of students who had previously regressed in mathematics. In fact, these students had a low performance in mathematics when I measured that, because I got their grades and scores from the previous year, okay? And implemented the tools and strategies to bring psychological safety, collaboration, relatedness, growth mindset, and autonomous motivation. evaluate the qualitative and quantitative before and after the intervention, and discuss the results with the student participants, giving them experience of statistics in real world. So we discussed our results with them. So this is the methodology schema. We had the reflecting, the planning phase where we established the strategies to promote mathematical resilience, the acting and observing phase, the evaluating phase, which measured and compared and we discussed, but we didn't have time to do the other cycle. Next time we can do the other cycle so that we can see whether it was more effective, okay? It took us 16 weeks to do that. So we studied first the scales to measure math anxiety, and a discussion of what scale to be used, understood and studied the 3 tools. We adopted the MASR scale questionnaire that we used. We reversed the positive questions so that high scores in these positive questions meant a high score in math anxiety, or a high math anxiety, okay? The planning phase, we had the application of the MAS-R, the before, where 28 students were suffering from high or very high, and the other students were still high. And we introduced the growth zone model, and the students were taught how to use long out breaks. Sometimes a permission to leave to have a break was given so that they could recover from. And here is my class. I'm so happy to bring this here. The hand model of the brain and the relaxation response were introduced. And you see the students positioning themselves. I gave him a challenge, a sentence. What do you feel when you learn statistics? What does statistics mean to you? And we gave them the following scenario. It's like a tiger entering the class. It's like resting on the beach. It's like being challenged. So they position themselves in this area. So after 6 weeks, I felt that the students were more participative and they felt safer asking questions, because in the beginning they were apathic, completely apathic. So, and at that time I make observations and took field notes of what they said. And the evaluating phase, the MAS-R was applied again, and it was possible to discuss statistical before and after with the students. So we had some quantitative results. Only 4 students, 13% scored less than 45 on the before measure, and the after measure indicate that 7 students, 22% scored less than 45. And evidence of math anxiety was observed in both positive and negative questions. But there was some improvement in positive questions. I find math interesting. I would like to take more math class, and I enjoy learning mathematics. These improvements indicated increased motivation within mathematics, okay? And the negative questions, math makes me feel nervous, math makes me feel confused, there was a decrease indicating a small reduction of in the anxiety level. They felt less nervous, less confused. This small scale, although, indicate the potential for this kind of intervention. And the sample was small, it was difficult to get p-values lower than 0.05, even if the intervention is effective. It's recommended for future studies a larger sample. And the qualitative data were analyzed using the deductive latent thematic analysis, working with subjective experience and using a pre-existing framework, the mathematical resilience framework. We looked for evidence of anxiety, psychological safety, growth mindset, motivation and value, struggle, and relatedness. So mathematics anxiety, evidence of anxiety and underlying experience, such as feeling lost in data, we found. For example, one student said, I'm nervous when facing numbers. I get so nervous in math tests that I always forget to sign my name on the test. So things like that. VMS, for example, I'm lost and confused in math classes, and I always do math tests as fast as I can to get rid of it. And another students, two students, I get lost in math explanations because it's too much information, so they were overwhelming. Psychological safety. So students expressed positive comments about the rhythm of the class. And so I think a safer environment was established. So LS said, I feel myself capable of doing these classes. However, I'm not capable in normal math classes. And there was the MCR story, because she always asked for help. Everything, any time in the class for help. And she didn't try for themselves. And there was a moment that the students, her colleagues, you must try, you must try. And she didn't, that didn't made her frightened or isolated or nothing like that. She participated, she understood, and she tried to make the exercise. This was fantastic. And psychological safety. So students expressed positive comments about the rhythm of the class, and a safer environment was established. I feel myself capable of doing this class, however, I'm not capable in normal math classes, okay? The growth mindset, so in their prior experience learning math, students demonstrated a fixed mindset, and I think that changed a little bit. For example, MCR said, I feel less dumb in your class. Today I have less difficulty in this subject, things like that. So, and motivation and value. We identified data which categorized as related to motivation to study maths and perceived value. So PhD said, time passes so quickly, he indicated substantial motivation. After classes, I got more interested in the subject. I feel classes are more interesting and more useful. And relatedness and struggle. So the teacher observed the learners forming informal discussions to find solutions to tasks that they were struggling with, even in the second week. So I think that the tools help them to communicate what they were, and they began to form groups of discussion in class. So this was very, very interesting. They were more participative and asked more questions. So I'm very happy to share these results of this very simple intervention I did in Brazil. And I think that statistics was used in a real problem for them, so it made sense for them, because sometimes you bring exercises to class that has nothing to do with them. They don't know where it comes from. So the intervention developed an environment of reduced anxiety and increased empathy and motivation in class. And I think it led to a more positive attitude towards maths. And it permitted a safer, collaborative, and empowering environment. I know the sample wasn't big enough to robust statistical evidence, but future large scales are desirable, and the intervention was, I think, was successful based on the qualitative analysis of the field notes. And we showed that learners' reports of anxiety and suffering towards mathematics before and reduced anxiety and suffering after was significant. And I think that this kind of intervention can make a difference in Brazilian students and in public schools in Brazil. And that's all. Thank you very much. If you have any